Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 5, Section 6, titled Working Backwards, or Work Backwards. By the end of this section, you will have reviewed the procedures for working backwards. This will include discussions on reading and understanding the problem, planning and solving the problem, and finally looking back and checking your results. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them. It certainly will help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Objective 1. Work backwards. Working backwards from a known information will sometimes help you solve a problem. Well, let's see how that works out. We're going to move into the next slide. So example 1, and I'm calling it 1A, it's a real-world problem, and it's going to take multiple slides. I'm not sure how many, 3, 4, maybe 5. I don't remember what it was exactly. It's a time management problem. And what we're going to do is we're going to find out that we're going to be planning to go to the baseball game that starts at 1 p.m., and you want to arrive 1/2 hour early. Your walk to the train station is about 10 minutes, so that's important. That's from your home to the train station is 10 minutes. The train ride is 3/4 of an hour, and after you arrive in the city, you'll walk another 10 minutes to get to the stadium. What time should you plan to leave home? So there's the question. What time should you plan to leave home to make all of this work? Okay, we have this 1/2 hour early that we want to be there a 1/2 hour early before the 1 p.m. game starts. So the number one question to ask and read and understand, because what we do now is read the info, understand what they're asking, and then answer some questions. So what do you want to find? Well, you want to find, I guess, the time you're going to have to leave home. Time to leave home. Okay, that's the time to leave home. So we can get to the ballpark by 12:30 p.m. Okay, what is the arrival time? Well, the arrival time has to be at the park at 12:30 p.m. Okay, so given that, how much time will you need to spend walking to the train? We know that's 10 minutes. How much time will you spend on the train? It says 3/4 of an hour. Well, that's 45 minutes. And then how much time will you spend walking from the train station to the ballpark, to the stadium? That's another 10 minutes. Okay? Good deal. So example 1B, so this is the second slide, plan and solve. So now we're going to plan when we leave the house and how we're going to make all this happen. So the question says, or the statement number 6 says, you know that the series of events must end at 1 o'clock, because at 1 o'clock the game starts. So all of these events that we're talking about are the train events and walking to and from the station or whatever, or from your home. Those are the events. That's the part of the series of events that we're dealing with. And that you want to arrive 30 minutes before the start of the game. Okay, work backwards to find when you must begin. So you're going to look at where we ended and subtract all the times necessary to find out, well, where we're going to begin. So at what time will we leave the home? Starting at 1 p.m., we're going to subtract the time required for each event to identify the start time of each event. So let's give it a shot. So the game starts at 1 p.m. 1 p.m. Okay, and that's this clock right here. The game starts at 1 p.m. So arrive at the ballpark. We want to arrive at the ballpark 1/2 hour early. So we take 1 p.m. and subtract 30 minutes, and we get 12:30. So here we are. 1 p.m., subtract 30 minutes, and now we're at 12:30. Then it says, arrive at the train station. Well, we're going to arrive at the train station. Actually, it says 10 minutes. We're arriving going backwards, right? We're leaving the ballpark and going to go to the train station. So at 12:30, we're going to have a 10-minute walk. So we're going to start at 12:30 and walk for 10 minutes. So we're subtracting 10 minutes. And at 12:20, right here, 12:20, we're going to be at the train station. Kind of going backwards. Okay? So then, now that we're at the train station at 12:20, we need 45 minutes on the train. So we've arrived at the station, and we're going to take 11:35. Is that? Oh, get on the train right here. Sorry. 12:20 and subtract 45. That's going to give us 11:35. So we go here and look back. We're going to go back 45 minutes. 45 minutes from 12:20. We're going to go 45 minutes. We'll end up at 11:35. So that's where we get 11:35 right here. And then we're going to arrive at the station because after 45 minutes, going backwards to our leaving station where we left from home, we're going to be there at 11:35. So now we're going to arrive at the station minus 10. That's the time it takes to get to the house. And that's going to give us 11:25. So from right here, from 11:35 minus 10 minutes, we're now going to be at 11, right there, 25. So what does that tell us? We have to leave home at 11:25. So that's working backwards to solve the problem so we can move forward. You can pause this and look at all these times if you like, and think about it if you want to just pause the video before moving on. So now we're example 1C. This is page 3 or slide 3. And now we're in the look back and check. So we've added up all of our times going forward, or we defined the times going forward. We subtracted them from the end point in reverse order so that we could find out when we're going to leave the house. And now it's time to find out if we leave the home at, what did it say, at 11:25, will we be at the ballpark, in our seat, watching the game at 1 o'clock? So it says, check the departure time and find the total time needed. Well, we know the departure time. So we need 10 minutes for walking to the station. We need 45 minutes on the train. We need 10 more minutes to walk from the station to the ballpark. We need 30 minutes getting to our seat. Okay? And should put us at the start of the game at 1 o'clock. So if we add all these up, it's 95 minutes. So add 95 minutes to your departure time. So we're going to depart at 11:25, and we're going to add 95 minutes. And if we do that, we're going to get, what says 120, which really means 120 is 2 hours. So that's the time we're going to be. Well, if you start at 11 and add 2 hours, 11 plus 2 hours is going to be 1,300, as they like to say in the Army or the Marines or whatever. So this is 1 o'clock. So this is 13. It adds up 11 and 2 is 13. And 13 converts to 1 p.m. We were successful. Okay, so for example 1, check your understanding. This is your turn to shine, so to speak. So here's the question. Suppose you must be home by 6 p.m. 6 p.m., you know what time you have to be home. So that kind of implies that there's a time you must leave the ballpark, right? So if the trip home takes the same amount of time as it did to go to the game, how long can the game run if you were to be home by this 6 p.m. time? So the game can run till sometime, and at that moment you're going to go and get on the train and take your time to get there. So when must you be home? That's your question. So go ahead, and that's where you're going to start. Stop the video, think about it, come back with an answer, and then we'll work it together. Okay, now that you've done that, let's start with the question number 1. It says, when must you be home? Well, the answer to that was easy. It's right there above us, 6 p.m. p.m. When must you leave the park? Well, the game, whenever you decide to get up from your seat, you got to leave that park at some given time to spend all your time going home. Well, what was that? You must leave the park 6 o'clock minus however many minutes it's going to take to get home from there, which would be the time you'd have to leave, thinking backwards. Right? Well, if I have to be home at 6 and it's going to take me 65 minutes to get home, then I better subtract 65 minutes from 6 o'clock. And that's when I better be leaving the ballpark. That's kind of how this is going to work. So, and I know it's 65 minutes. And how do I know it's 65 minutes? Because the time it took to get there was 95 minutes. But we allowed 30 minutes of getting a hot dog and whatever, Coke at the concession stand or something, or finding our seat. So we don't have to do that now. We're just going to get up and leave the park and go to the train station. So it's 95 minutes, and we can subtract the 30 minutes that we wanted to spend getting from the door of the stadium to our seat. So we're going to subtract 65 minutes from 6 p.m. So if you subtract 60 minutes from it, it'll be 5 p.m., and 5 more minutes. It means that we're going to be having to leave the ballpark, at 4, what? 5 o'clock minus 5 minutes is 4:55. Okay? So 4:55 is p.m. is when we have to leave the park. And how long can the game run? Well, if you take 4:55, so we're going to take what are we going to subtract from that? Well, when did the game start? It started at 1. The game can run from 1 o'clock to 4:55. Well, 4:55 minus 100 here. We're going to just subtract 1 hour from here. So the game can run 3 hours and 55 minutes. Oh, I'm just going to not say 55 minutes. Just 3 hours 55, okay? That's what we're going to say. That's the answer to our question.